Hi, everybody. I'm John Mailhot, and for the purpose of the next 5 minutes, I'm the chair of the Ground to Cloud, Cloud to Ground ad hoc group, GCCG, easy to say and hard to say all at the same time. Now, this particular ad hoc group has been operating in parallel with the group that's been developing TR09, and with a little bit different objective. TR09 was, 2110 over WAN and evolved to also include the management protocols that go with that. We've been taking a more holistic approach and looking at the whole ground to cloud to cloud, and cloud to ground workflow, and trying to identify, are there gaps, are there needs, and if there's gaps or needs, who's filling them, or how do we get somebody to fill them, or worst case, what do we need to do to fill them? And so each of those workflows has a story, and we'll talk about them in a moment. Now, when I talk about cloud to cloud, by the way, I really mean within a single cloud provider, within AWS or within Azure or whatever. There's a whole nother use case that's like cloud to a different cloud. We kind of view that as being just similar to cloud to ground or ground to cloud. It's, so they'd be presumably completely different in arm's length. One of the first things we looked at is, what are the operating points? What is the kind of video quality and codec kind of aspiration that you would use? And we saw pretty quickly there were three use cases that were happening in the wild. There was a low rate, Zoom or better kind of bandwidth optimized use case, which has a lot of ways people do it, and they're kind of out, in practice already. There's the middle kind of interactive latency, short GOPS, progressive refresh, H.264, NDI probably fits in that camp in some way as well. And then there's the, what we're jokingly calling premium compressed, which would be JPEG XS or similar kind of high rate codecs, really optimized around the low latency, high bit rate, high quality corner of the cost capability pyramid. And those are where the work of the VSF is sort of focused right now. The other two use cases are happening in the wild. They seem well supported. So as we think about these use cases, really the point becomes, what are the planes of interoperability? Where are the places where you would expect to have different vendors at either end of the wire, or a workflow assembled of parts that come from different people? Because that's the point of standards, is to enable the interchange of these signals cleanly and reliably between different systems built by different people. So one important handoff point, of course, is the ground to cloud case. And there we need to spec all the way down to the IP layer, because fundamentally that IP stream is what's going from the ground to cloud. And so that's where the work of, say, TR09 is probably the right thing to do there. TR09 with JPEG XS, TR08, and so forth. Then same thing on the way back out of the cloud, assuming that you're coming back in a production quality level, you would use that same stack of standards to get out of the cloud. Within the cloud, one thing we realized pretty quickly, whether it's the cloud or whether it's a private cloud or a public cloud or what, there's different technologies under the hood in different cloud providers. So AWS has some specific technologies for transitioning, high quality buffers of video between instances. Other cloud providers have similar but different capabilities. If you're building your own private data center, you might want to build your own stack of stuff that does that. So rather than try and specify that interop point all the way down to the IP packets, since in some cases they might not even be built in IP, we said, well, let's try and specify it at the buffer level, at the what is the blob that we're handing off, and then have presumably provider specific capabilities for getting it from there to here or here to there. So that's the, that big yellow bar in the middle is really the interop plane inside a cloud provider. Now, all that said, then you get into the case where, there's a lot of groups working on this. So the actual ground to cloud and cloud to ground has been covered very adequately in the work of TRO 7, 8, and 9 by design, right? We all talk to each other. Those groups focused on that use case. TRO 7 and 08, John Dale talked through earlier. They're done, published, and about to be updated. The TRO 9 will be published soon, very soon, or as the joke goes, soon, only not yet. There's, for the middle cases, the transport stream IPH264 kind of cases, they abound in the wild. So in theory, you could use the TRO 9 control plane possibly to add some value to those, to harmonize how they're sent around. But there's enough work going on in the wild that that would be the standard, chasing the application instead of the other way around. Then the unique work in this group has really been around the time flow, time tagging within the model, within the cloud. If you have instances, and this kind of gets back to our first talk of the day or second talk of the day from Mr. Rayner about making us less dependent on that rigid, everything happens on a frame boundary model. There's no reason for that in the cloud, right? But if you don't have that, how do you express the timing of things? And then, of course, when you're handing off between between containers in a cloud, what is it you're handing off? Because there's some work there. So all to say, we spent a fair bit of time over the past so many months talking about this variability and time floating challenge, where you want to allow the applications to be variable in how they deliver things, but yet be bound so that you can, when you need to, because you always need to eventually, you can reassemble a linear stream, and you want to know what, how much buffering you need to do that. So we talked through, where does the variability come from, and came up with a vocabulary for how to actually track it, and ultimately came up with a way of expressing the spec of how long does it take and how variable is it, around that, expected value, and even did some, math around how, if you have a sequence of steps and each step is variable, how does variability accumulate as you go down that chain? Because ultimately, if you have a consumer at the end of that chain, it needs to know how late could it be, or how early could it be as well. And so this allows us to capture the, both cases of lateness and earliness. All that said, where are we today? So I think for the ground to cloud and cloud to ground cases, our expectation is that between TRO 7, 8, and 9, the high quality case is documented, is published or soon to be published, and we mostly as an industry have to get on with doing it and using it. For the handing off between instances, there's a couple of things that are, need attention and are getting it in various stages. So how senders and receivers actually, identify themselves. The concept is we're going to use NMOS, similar to what's been done in TRO 9, honestly, maybe even with registry, where, we'll use NMOS to identify the senders and receivers because everyone knows how to do it. The ISO 5 part of that will need some extension to capture these new content formats. So the lingo of how do you describe the content, the ISO 5 or ISO 4 flows probably do that okay, but the transport parameters within a cloud are going to be very specific to the cloud provider. So there is some work in progress starting in the AMWA on that, and anybody who wants to be a part of that, the AMWA is always looking for new members too. I say that with my AMWA board hat on, with my VSF hat on. I say, hey, we're doing it here too. And then in addition, this timing work that we've done needs to flow along that same connection and talk about, not just what am I sending if I'm a sender, but what's my, and what is its transport parameters, but also what is its variability in the time domain. Now, there's also a lot of discussion that we've had about the format of these buffer handoffs, and there's work in progress on the VSF GitHub about that, and proposing a very neat tidy format that's very software friendly. But some work that's already been done in the cloud was built on the sort of 2110 concatenated P groups, which, while they're not perfect for any specific purpose, they're perfect in the sense that they're written down and they're already achieve some amount of use case, and people can unambiguously say, I'm doing that, and everybody reads it the same way. So there's some benefits and some curses to that specific format, but that might be the canonical format. And then we say, okay, let's have a way of describing other formats like the standard Windows buffer format or this VSF CEF format that we've started talking about. Similarly, audio and metadata, there's just a need to have a written down spec there, but it's work to do. And then that's kind of the state of affairs of the thing is, we're sort of closing off those edges. The AMWA is taking the lead on these ISO 5 extensions, and we're looking to help them and work with them. And there we go. So ultimately, we get back to this idea of what are these planes of handoff. So we have this JPEG XS, TR09 interop point going ground to cloud and cloud to ground. And then between instances in the cloud, we have a well-defined application handoff from buffers and application space to the cloud provider specific transport. And the work in progress is how do we identify those senders and receivers in a way that something can match them up at runtime. All that said, that's the work of the VSF cloud to ground, ground to cloud group. And look forward to any questions you have before I turn it over to Mr. Gomer.
Okay, great. Thank you, John. And I assume, as usual, if anybody has any questions or wants to get involved, they'd be welcome to contact you about that.
Contact me, or better yet, contact Bob, join the group, join the fun.